Hi, this is Dr. Jennifer Stuckey with Southeastern University. Today I'm going to show you how to interpret a basic linear programming model. Linear programming can be a very powerful tool for business because it can allow you to optimize a model. So it can allow you to, given a set of constraints, it can allow you to either maximize costs or minimize expenses or set something to a specific value given a set of constraints. You should have already learned how to create a very basic model in your MyIT Lab exercises. But what I'm going to do today is take a model and talk to you about how to interpret it. And you're going to need this information for your discussion forum. So first of all, here's our prompt for this model. A farmer owns 450 acres of land. He is going to plant each acre with wheat or corn. Each acre planted with wheat yields 2,000 profit, requires 3 workers, and requires 2 tons of fertilizer. Each acre planted with corn yields 3,000 in profit, requires 2 workers, and requires 4 tons of fertilizer. There are currently 1,000 workers and 1,200 tons of fertilizer available. So that's the basic prompt we're working with. Again, at this point, I'm not showing you how to create this model. I'm going to talk you through how to interpret this model. What meaneth this? So, first of all, let's talk through the given information in the problem. The given information in the problem in this interpretation is already highlighted in blue. So, this is telling us that we profit $2,000 when we plant an acre of wheat and $3,000 when we plant an acre of corn. And some students will say, well, we make more money with corn, so why don't we just plant all 450 acres with corn? Well, I'm going to show you what that would look like in just a few minutes so you can understand why that doesn't work in this problem. But in any case, this is just given information from the problem, as is this text right here where it says wheat takes 3 workers and 2 tons of fertilizer and corn takes 2 workers and 4 tons of fertilizer. This acres planted that's highlighted in what is that, salmon? Light pink, whatever we want to call that. That tells us how many acres of wheat and corn should be planted. So you reference acres planted, wheat, corn, okay? And so what this is telling us to do is that we're going to plant 200 acres of wheat, and we're going to plant 200 acres of corn. So these are called our decision variables. So this is what the farmer actually has control over in this prompt, is how many acres of wheat to plant and how many acres of corn to plant. So this is a very important information when you are writing out your discussion forum, is what are your decision variables, and to make sure that you have the decision variables in your plan. Because it's all great that you have come up with a way to make $1 million in profit, but if you don't tell the farmer how to actually do that, then how is he going to know? There's no way to enact your brilliance, or your brilliant plan. So you need to make sure that you give the decision variables. In this case, the decision variables would be 200 acres of wheat and 200 acres of corn. All right, so one of the main constraints in the problem are that there are only 1,000 workers and 1,200 tons of fertilizer available and 450 acres of land. So these are all constraints because the farmer cannot use more than 1,000 workers, more than 1,200 tons of fertilizer, or more than 450 acres of land. So that means that these resources used and acres used all have to be less than or equal to these that are available. And so let's talk about this. So these are, in this column, in column B, cell 19 and 20, you can see my cursor, these are the resources that were actually used, okay? In column D over here, in rows 19 and 20, these were the resources that were available. So in this case, you can see that they used 1,000 of the workers, and there were 1,000 available. So there were no extra workers available. They used every single worker that was available. That would be called a binding constraint. The fertilizer used would also be considered a binding constraint because, again, there was none left over. There was 1,200 tons available and 1,200 tons used. The constraints on acres, if you look, you will see that 200 plus 200 is 400. So they only used 400 acres of the 450 acres available. That means that there are 50 acres that are left unplanted. Why is that? Because there's not enough resources up here. These were binding. In other words, you couldn't plant any more than this and maximize your profit because there was not enough workers available and there was not enough fertilizer available. So this acres used would be considered a non-binding constraint on this problem at this time because you maximize your profit without maxing out the number of acres used. So they had 50 acres left that were unused because that's the difference between what was actually used and what was available. The profit is also a really important cell. So this is considered the objective cell, maximizing the profit, and this profit is it's maxed out at $1 million. So when you plant 200 acres of wheat and 200 acres of corn, then you make the farmer would make $1 million in profit. Let's go back to the constraints real quick. I want to show you why you can't just plant 450 acres of corn and call it a day. All right. We could plant 450 acres of corn, and if you look at the resources used down here, you've only used 900 workers and you had 1,000 available. So that one's good. Your acres used are also good. You've used 450 acres and 450 are available. Your profit looks even better than the last one, 1,350,000. The problem is that to enact that plan, you have used far more fertilizer than you actually have available over here. This plan uses 1,800 tons of fertilizer. You only have 1,200 tons of fertilizer. So if you try to plant corn, a bunch of them are going to die or not grow to maturity because you don't have enough fertilizer. And so that's why you can't just go, oh, what's the highest profit, and use those numbers, because the constraints sometimes affect how much you can actually earn from the item. So this is why Solver is important, and the more constraints that you have in a problem and the more complex it is, the more helpful Solver can be over just trying to sit there and figure it out by hand. So in your discussion forum, when you talk about your linear programming model or your Solver model, make sure that you mention the following information. The decision cells. On this particular model, it would be acres planted. That's going to be different in your model, but it is critical. It is a critical number to discuss. Again, because if you don't tell your client what the plan is, how on earth are they ever going to follow it? You need to discuss the objective cell. This is a main piece of justification for why your plan should be followed. Okay. The last thing you need to discuss is the constraints. Depending on how the constraints work out in your model, you can just do a basic listing of these are the constraints. The other thing that you can do is, like in this case, where you had 50 acres unused, I would draw that out separately and discuss that, even though there were 450 acres available, only 50 were unused. And it's also important to know that the binding constraints are labor and fertilizer. What if there were a way to procure more of these things? The farmer might be interested in knowing that they could drastically increase their profit if they could get either more labor or more fertilizer. So I hope that this video has been helpful in interpreting your Solver models. And if you have any questions, please reach out to your professor. Thank you.